Now we're going to move on to 10.4. 10.4 is actually a lot like 10.2, not 10.3. 10.3 uses the t distribution, but 10.4 goes back and uses the z distribution, the normal distribution again. So this one, I'm going to do number 5, 10.4 number 5. You can see it's a left-tailed test. So I'm going to go over here and I'm going to copy my first left-tailed test, right? Why not? I'll use it as the basis of what I'm doing and then I'll change things. Or you could just type it all, that's no big deal. All right, so the null hypothesis we're dealing with is a p now, not mu. Level of significance is alpha. Population standard deviation, that's not given to us in this case. We're going to do number of successes, x in this case. All right, then we're going to do sample size, and then we have sample proportion now, which is p hat, not x bar. We're not working with mu and x bar anymore, or sigma for that matter. We're working with p and p hat. All right, so let's get this much done. P was 0.55 for this problem. Alpha is 0.10, there it is, 0.10. The number of successes we have is 78, so 78. N was 150. Our p hat is x over n. We learned that in section 9.3. So you take 78 divided by 150. Just type that formula for you real quick. Equals x over n, right? We learned that back in chapter 9. Standard error. All right, this is not standard error of the mean anymore. It's standard error of proportion. Okay, that is sigma p hat. Let me insert sigma. Oops, I didn't just do that. Yes, I did. That was dumb of me. I pressed cancel instead of close. All right, sigma p hat. Now we learned the formula for that. I know you don't believe me, but we learned it way back in chapter 8. Let me go see if I can find it. I think it's on page 446. Yep, there it is. Chapter 8, 8.2. There's the formula right there. Sigma p hat is the square root of p times 1 minus p over n. So let's set it up. Right here, standard error. Why am I not capitalizing the e? Because I'm a moron. There we go, e. Okay, equals square root, parentheses, p, that's 0.55, times symbol, parentheses, 1 minus p again, so 0.55 again. Close one of your sets of parentheses, but not both, right? They're green, right? See the green parentheses? Keep those together. Divided by n, which is 150 for us, that cell. And again, you are so much better off using cell references here. That way when you copy and paste for the next problem, it's all there. All right, next, the lower critical value. The critical value is norm S inverse of this alpha, right? So that's all set, done, right? No troubles there. The test statistic. The test statistic is, let's click this, the standardization of B, right, 5, which is P hat, B5, with B1 as the mean, and B7, right here, as the standard deviation, aka the standard deviation of the sample proportion, aka sigma sub P hat, this guy right here. There we go. Now the p-value is norm S dist of that test statistic. We're golden. All right, so are we going to reject? Look at these two. If this one right here is lower than this one, we reject, which it is not, so we do not reject, because z0 equals negative 0.74 is not lower than the z alpha. Or you can see it because the p-value is not lower than alpha. Oops, we do not reject h naught, always h naught, because p is not lower than alpha. All right, we're done with the first one in 10.4. I'll see you here for the right-tailed test one next.